Last on our list is complex fractions, and they are complex, but this is definitely doable algebra. You just have to get used to that, seeing the simpler work within these really messy problems. So there are actually two ways to approach this. I'm going to show you my favorite first, and it's my favorite because it's the most efficient. And we actually have to do quite a bit of simplifying complex fractions to work with rational functions, which is then going to show up in early calculus especially, but throughout calculus, complex fractions happen. So first way, most efficient, but it also has the most amount of work done in your head. And it sometimes doesn't quite click with people why it works the way it does. So I will show you the other way as well, and you can choose what you like. Okay, so option number one is to approach this sort of like we approach the equations. You can actually do some fraction clearing, and you have to be careful. The reason it works the way it does for equations is because as long as you multiply both sides, you've maintained the balance of the equation. With an expression, there's no equal sign in this. You have to maintain the value of the expression, or the fraction in this case, the big fraction, which means the tools we have are multiply by 1, multiply top and bottom, or add 0. Sometimes if you add and subtract the same thing, you can get some nice simplification done. The one you see the most for now is that multiply by 1, and that's what we'll use. The version of 1 that we want is the one that will cancel out all our denominators, and it turns out that that means that what we want is the least common denominator multiplied top and bottom. Usually you're going to have linear factors in here, but if there's something quadratic, you might have to factor even more. But what I'm seeing is I want to look at all the little fractions inside the big fraction and see what's going on with their denominators. So looking at the first fraction, I'm using x, but this is m. I will need an m minus 4 to cancel out its denominator. For the second fraction, I will need an m plus 3. For the bottom first fraction, I've already got an m plus 3, and bottom second fraction, I've already got an m minus 4. So this will be my tool. So m minus 4, m plus 3 on the top, m minus 4, m plus 3 on the bottom. And if it helps, this looks awful, I know, but just to see how things are going to line up, you can put those over 1. So we'll be multiplying into the top, and we'll be multiplying into the bottom. And do not forget this distribute. That will make everything kind of a disaster. So I'm going to write out fully what this looks like, but this is another one with the equations, where if you can kind of start to see what's going to happen, you don't have to write this part out. This is the things can be done in your head part. Oh my goodness, I can't write a 7 right now. Okay, 7. And I need to multiply it by an m minus 4, m plus 3. And then on the bottom, I have an m minus 4. Second fraction, I need to multiply 5 by m minus 4, m plus 3. And I have n m plus 3 on the bottom. Down below, I have a 5, m minus 4, m plus 3 over m plus 3. And last but not least, the 9 gets multiplied by the m minus 4, m plus 3, and that is over m minus 4. So every single term within this fraction needs to get multiplied. Sometimes you'll run into one where not every single term is a fraction. Still have to multiply it by the m minus 4, m plus 3, or whatever your LCD is. Okay, so here's the magic. I get to just start crossing things out. An m minus 4 cancels out of the first fraction, an m plus 3 from the second and third fractions, and an m minus 4 from the fourth fraction. So this will turn into, what is it? A 7 times m plus 3 minus a 5 times m minus 4. So that's all that's left on top, right? The 7, the m plus 3 minus 5, and m plus 4. On the bottom, it's a 5 m minus 4. I think I just said that minus wrong, but m minus 4 plus a 9 m plus 3. So 5 m minus 4 plus 9 m plus 3. Okay, so for the sake of being able to fit the other version of this, I am going to do a little bit of my simplify as scratch work here. So I'm seeing a 7m plus 21 minus a 5m plus 20. And down below, I'm seeing a 5m minus 20 plus 9m plus 9 times 3, 27. So all together, I get 7m minus 5m on the top, so 2 m's, and a 21 plus 20 plus 41. On the bottom, 5m plus a 9m is a 14m, and then a negative 20 plus 27 is plus 7. I could factor a 7 out of the bottom, but I can see that there's nothing to factor out of the top, so I won't be able to cancel. So if you can tell without doing the factoring that the fraction won't reduce, you can be done. If you can't tell, if you're not sure, make sure you factor top and bottom and see if you can reduce the fraction that you end up with. Okay, so that was option number 1. Option number 2 is to treat this as a subtraction problem in the top, an addition problem in the bottom, and then lastly, we need to divide the two fractions we end up with. So basically the thinking here is we are dividing fractions, and the way you divide fractions is to flip and multiply, but that only works if you have a single fraction divided by a single fraction. So you would actually just follow order of operations here, which says, remember, fraction bars are grouping symbols. They're like parentheses, so you have to do all the work within the fraction first, and then you can do the division as your last step. So we will have to build up the common denominator for each of these fractions. I'm going to erase off a little of my mess. So this approach will say, what is my fraction missing? Let's multiply by that. So the first fraction will get multiplied by an m plus 3. The second fraction will get multiplied by an m minus 4. Note that when you do this, you're looking at the top and the bottom as totally separate fractions. So here it doesn't matter because the denominators for the top and the bottom are identical, so both would have the same LCD. But it is possible with this method for the top and bottom to have a different LCD. That's totally fine. So what do you need to do to make the subtraction work on top, and what do you need to do to make the addition work on bottom? So here I'll need an m minus 4, and here an m plus 3. Okay, so I end up with a 7m plus 21, that should look familiar, over m plus 3, m minus 4, minus a 5m minus 20 over m plus 3, m minus 4. And then on the bottom, I have a 5m minus 20 over m plus 3, m minus 4, and last, a 9m plus 27 over that same LCD. Okay, so when we go to do this addition subtraction, that basically means you can combine them into a single fraction. So I'm going to get a 7m plus 21 minus a 5m minus 20. I'm being very careful with parentheses. Since the denominators are all the same here, I'm going to do my shorthand temporarily and write that as just LCD. On the bottom, I have 5m minus 20 plus 9m plus 27. Notice that the extra parentheses on the bottom aren't actually needed because it's addition. The top is the only place that they're important, but I thought I'd throw them. You could even have them around these, but only where there's that subtraction attached do I actually need them. So I'm just going to be really, really careful and make sure that I turn that into a plus 20. That's the big thing there. However you're careful about that will be fine with me. Okay, so I am seeing a 7m minus a 5m, so this is very similar work again, right? I have a 2m, and then it's a plus 21 plus 20, so plus 41, over, I'm going to write the denominators out again, m plus 3, m minus 4 all over 5m plus 9m, so there's a 14m plus 7, divided by m plus 3, m minus 4, and I have just a little extra room here. So to divide fractions, now that it's a single fraction over a single fraction, you flip and multiply. So the top stays exactly the same. And then we flip the bottom one. And notice that those denominators cancel out exactly. Sometimes there'll be a little difference, so you'll only be able to cancel part of it, and that's okay too. But here they completely cancel, and I'm left with 2m plus 41 over 14m plus 7. So you take your pick. I think if you're comfortable with the top method, you don't have to write out that big first step that I wrote out. You can skip straight to, let me show you this right here, as you get comfortable, and it makes it a lot quicker, and we do use this a lot, so that's nice. But if you find yourself making mistakes, please write it out carefully, make sure you understand the steps that are going into it, and you can use the second method.